Okay, Pre-Cal, this is the very first video of what you definitely should have on your note card as far as vocabulary for an ellipse. And this is an ellipse, and this ellipse has a horizontal major axis. We're going to find the center point first, and we're going to go through each part and label everything so you have all the information that you need to speak intelligently about an ellipse. So first of all, let's go through and let's start labeling the figure here. So we have our center point at 1, 2, 3, back 3, up 2. So back 3, up 2. So that's going to be our center point at -3. We'll deal with that in just a moment. Now, I mentioned that it has a horizontal major axis. I'm going to mark that in yellow. So here is our major axis, and then I'll put our minor axis in orange. And the minor axis is minor just because it's shorter. Nothing more than that. Major axis is longer, minor axis is shorter. So our major axis, and I'll go ahead and I'll change this to major axis endpoints and minor axis endpoints. They also have another name. We'll get to that in just a moment. Foci. Foci, of course, is plural for focus. So one focus, two foci. And it's not foci, it's foci. And that's just what it is. So major axis endpoints are there and there. So that is over 1, up 2. So we have a major axis endpoint at 1, 2, and we have a major axis endpoint at 1, 2, 3, 4, 5, 6, 7, up 2. So -7. Let me check that again. 1, 2, 3, 4, 5, 6, 7. Yes, -7, up 2. So that tells us a couple of things. These are actually vertices, the endpoints of the major axis. We can call them our major vertices. And then our minor axis endpoints, we've got one up top, one down bottom. So that's 1, 2, 3, back 3, up 1, 2, 3, 4, 5. So -3, 5. And then, of course, -3, -1. Those we can also call them minor vertices. So our major axis has endpoints. Those endpoints are major vertices. Our minor axis has endpoints. Those vertices are minor vertices. Now, if we see semi-major and semi-minor, that starts getting into something really important. In semi-major, we're talking about the length of the semi-major axis. And remember that prefix semi just means half, just like semicircles, half a circle. So the semi-major axis has a length of 1, 2, 3, 4. So that is A. That is our A value. A is equal to 4. So I will make that solid and now clearly say that A is 4. And A has everything to do with the major axis. So obviously if A is 4, then 2A would be the length of the major axis, and the major axis full length would be 8. Okay, semi-minor axis, another very important value here. It's just half the minor axis, and of course that is 3, and that is the B value. So A is the longest, it's 4, B is the minor, it's 3. So a semi-minor axis length B equals 3. Now, if we know A and we know B, then we can find C, and C has everything to do with the foci and the eccentricity of the ellipse. And the eccentricity of ellipse is basically how, you can think of it two ways, how not round like a circle it is, or you can give it a fun word that I have coined, how ovalicious it is. So how ovular or how ellipsilicious that the ellipse is. So that is its eccentricity, and that is a ratio. And it does go into that on the Math is Fun website, but the easy way to think about it is just that E equals C over A. Well, we got to find the C value. So how do we find this C value? Well, the C value is found, C squared is actually equal to A squared minus B squared. This is not a Pythagorean relationship here. So don't get that confused with Pythagorean theorem. It's not that type of relationship. So if A is 4 and B is 3, then C squared equals 16 minus 9. C squared equals 7. Therefore, C is the square root of 7. So that means that we have an eccentricity here of root 7 over 4. Okay. Now, this C value also tells us where our foci are. Our foci always live on the major axis. Foci always live on the major axis. And if the A value is the distance from the center point to a major vertex, the B value is the distance from the center point to a minor vertex. The C value is the distance from the center point to a focus. So, in this case, since our center point is at -3, 2, our foci are going to be at -3 plus root 7, 2, and also at -3 minus root 7, 2. So just to give us a little better orientation of where to put that, the square root of 7 is equal to 2.645 and some change. So we're going to say about 2.65. So approximately 2.65. So basically we're going to go to that center point and go over 2.65, which, so 1, 2, and there's a half. So about right there is a focus. And then back to 0.6, which is about there as a focus. So focus number 1, focus number 2. So center point, foci, the endpoints of the major axis, which are the major vertices, the endpoints of the minor axis, which are the minor vertices, the eccentricity of this ellipse. It has a ratio of root 7 over 4. And obviously I gave you the drawing. So we'll get to the perimeter and the area in just a moment. Let's go ahead and let's write the equation of this ellipse, because we have all the information that we need now to do that. So here is something to definitely write down if you haven't written this down yet. In order to find the equation of the ellipse, the general form, so I'll write the general form right up here on the top. General form not at the origin. And in this case, since the major axis is horizontal, then A will go underneath x. So x minus h squared over a squared plus y minus k squared over b squared equals 1. This is something to keep in mind. These equations are always going to be set equal to 1, different from a circle. So we know h, we know k, we know a, we know b, we know all the information that we need in order to write the equation of this ellipse. This particular ellipse is going to be x plus 3 squared over a squared, so a is 4, so over 16, plus y minus k, so y minus 2 squared, over b squared, b is 3, so over 9 equals 1. So this is the standard form of the equation for this ellipse. Now, let's find the perimeter and the area for this particular ellipse. We have an approximate formula for the perimeter of this ellipse. Honestly, I have no idea why this works in the way it does, but this is one that's given, so this is one we're just going to roll with. So there's that formula. So approximately 2 pi and then a squared plus b squared, so that's going to be 16 plus 9, so that's 25. So that is going to be the square root of 25 over 2. I'm just going to go straight to the calculator here for a decimal approximation. So 2 pi times the square root of 25 over 2, which is 12.5. I'll go ahead and I will go there. And that's going to give us 22.21 we'll just say units. We're talking about perimeter, so that's linear. Now area is super easy to understand. So if we can grasp hold of the fact that really a circle is an ellipse, it's just an ellipse whose foci have converged at the center point, because a circle is going to have an eccentricity of 0. So if the area of a circle is pi times r squared, and in the circle, the r, the radius, is a constant measurement, instead of r squared, all we got to do is say pi squared times a, or excuse me, pi times a times b. So to find your area of your ellipse, it's quite simple. It's just pi times a times b. We don't say r squared because the r is not constant here. It's changing a bit. So this is kind of like a radius, but they're different lengths. So the area here is pi times 3 times 4. That's 12 pi. And the approximation of 12 pi is 37.7. We'll round there since that's such a nice tidy number. But this time, of course, it's units squared. So this is all the nuts and bolts of what you have to know in terms of vocabulary and diagram of an ellipse. This is all must-know information, and you should definitely have this on your note card.